Okay, this is Go Math lesson 12.7. It's on statistics and probability. The standard is 6.SP.5D. It's on the effects of outliers. The essential question is, how does an outlier affect measures of center? So an outlier is a value that is much less or much greater than the other values in a data set. An outlier may greatly affect the mean of a data set. This may give a misleading impression of the data. So the table gives the number of days that the 24 members of the Garfield Middle School volleyball team were absent from school last year. Does the data set contain any outliers? So we're going to use a dot plot to find the outlier or outliers. Step 1, plot the data on the number line. So when I look at it, I have threes. So I have 1, 2 threes. We've done dot plots before, so that's review. Fours, I have 1, 2, 3, 4, 5. Fives, 1, 2, 3, 4, 5, 6, 7. Sixes, 1, 2, 3, 4, 5. 1, 2. When I continue to plot my points, I have 1, 2, 3, 4, 5 sixes, 3 sevens, 1 8, and then I had 1 16. So step 2, it says find any values that are much greater or much less than the other values. Most of the data values are between 3 and 8 because I have this huge cluster of numbers all right here. Then I have this 16. So the value 16 is much greater than the rest of my data, so 16 is an outlier. Number 1, generalize. What effect do you think an outlier greater than the other data would have on the mean of the data set? Justify your answer. So the outlier would make the mean greater than it otherwise would be. The mean is the sum of the data values divided by the number of data values. So a large outlier would make the mean greater. Example. The high temperatures for the week in Foxdale in degrees Fahrenheit were 43 degrees, 43, 45, 42, 26, 43, and 45. The mean of the data is 41 degrees Fahrenheit, and the median is 43 degrees Fahrenheit. Identify the outlier and describe how the mean and the median are affected by it. So when I go through and I plot these, I had 343 degrees, I had 142, 245s, and then I have 126. So the outlier is 26 degrees Fahrenheit because it's much smaller than where my cluster is, so it's my outlier. Step 2, find the mean and the median of the temperatures without the outlier. So that means I'm going to drop that 26 out of my data. So I have 43 plus 43 plus 45 plus 42 plus 43 plus 45. And then I'm going to divide it by 6 because now I have 1, 2, 3, 4, 5, 6 data values. So when I added up all those numbers, I got 261. And then I had to go 261 divided by 6. And I had to add a decimal and bring a 0 down right here. So it ends up being 43.5 or 43.5 degrees Fahrenheit. Then I need to find the median without the outlier. So I need to order my values from least to greatest, but not counting my 26. So it's 42, 43, 43, 43, 45, 45, and 45. So I have 2 numbers in the middle because there's 6 data value points. So 43 and 43. But there's nothing between 43 and 43. So my median is 43. But they showed you how to do that in case you're not sure. So you can add 43 plus 43 and divide it by 2 since there's 2 numbers in the middle, which would be 43 plus 43 is 86. And then 86 divided by 2 is 43. So you still get 43 because there's nothing between 43 and 43. So the mean with the outlier is 41 degrees Fahrenheit. And the mean without the outlier is 43.5 degrees Fahrenheit. So the outlier made the mean lower because with it, it was 41 instead of 43.5. The median with the outlier was 43 degrees Fahrenheit, and the median without the outlier is 43 degrees Fahrenheit. The outlier did not affect the median. It didn't change it. The number in the middle was still 43, regardless if the 26 was there or not. Number 2, use reasoning. Explain why the mean without the outlier could be a better description of the data set than the mean with the outlier. So 6 temperatures were between 42 degrees Fahrenheit and 45 degrees Fahrenheit. So the mean without the outlier is in the middle of most of the week's temperatures. The mean with the outlier is less than all but one of the temperatures. So it is not the best measure of the center of the data. Question 3. If the outlier had been 59 degrees Fahrenheit rather than 26 degrees Fahrenheit, how would the mean have been affected by the outlier? Explain your reasoning. So an outlier of 59 degrees Fahrenheit would be greater than the other data values. So the outlier would cause the mean to be greater than it otherwise would be. Okay, I'm going to do 2 more examples. Number 1, find the outlier by drawing a dot plot of the data. So I don't have any zeros. Ones, I have 1, 2, 3, 4. Twos, I have 1, 2, 3, 4. Threes, I have 1, 2, 3, 4. And then I have a 15. So obviously the 15 is my outlier. It's way far away from the cluster of data. So here's my cluster. This 15 is much larger than the cluster, so it is my outlier. Remember, an outlier is a lot smaller or a lot larger than the cluster of data. Number 2. Prices of the X40 laser printer at 5 different stores are $99, $68, $98, $105, and $90. The mean price is $92, and the median price is $98. Identify the outlier and describe how the mean and the median are affected by it. So the outlier is the $68 because it's much lower than the rest of my data values, which are around $100. So now I'm going to add the other 4. I accidentally added the mean in earlier. So I'm going to have 99, 98, 90, and 105. So I have 17 plus 5. And then I have 9 times 3, 27, 28, 29, 392. And then I'm going to divide that by 1, 2, 3, 4. So I have 9 times 4, 36. So $98 would be my mean. $98. Okay, now I'm going to find my median. So my median out of these data values, 90 is my smallest number, then 98, then 99, and then 105. So I have 2 numbers in the middle. I have 98 and 99. Well, right in the middle of 98 and 99 is 98 and a half, so $98.50. If you don't know how to do that, you can add these 2 together, 98 and 99, and divide by 2, but you're still going to get $98.50. So that would be the median. And then I'm supposed to compare that. So without my outlier, my mean is 98. It was 92 with it. So you can see without it, it's much higher. That's because my outlier was small and it was pulling my mean down. Okay. Then my median with it was $98, and without it, it's $98.50. So it affected it, but just slightly. So it says the outlier decreases, though, both the mean and the median because it's so much smaller than the rest of the data values. If you have any questions, leave them for me on the classroom. Thank you.